Hello everyone, Jai Hind and good morning to everyone. I'm very sorry for the technical glitch that happened and you were not able to join the session. We'll start the session again, once again, and we'll be covering everything that we have covered so far. Only Sonali was there. I guess Sonali has joined. Okay, that's nice. All right. So we'll be starting off again afresh. Sonali, that would be a quite another revision for you. But for the others, this would be a completely new class. All right, do not worry. And like I said, when I started the session, I said that, this session is very, very important. This session is important because, all the things today that, the concept that we'll be understanding, those concepts are very important for understanding the geomorphic processes as well as geomorphology of the earth. Now, what is geomorphology? I have told you. Geomorphology is actually the various landforms that we see on the surface of the earth. So these landforms are created or they have been formed due to numerous processes. And the most accepted, or I will say the most reasonable theory for the process, the geomorphic processes which happens deep inside the earth is the plate tectonics theory. So we'll be covering the plate tectonics theory as well in today's session. So we'll be covering the geomorphic processes as well as plate tectonics theory in today's session. So let's start the session. Let's begin the session. Now, when we talk about the geomorphic processes, what are geomorphic processes? Geomorphic processes are basically those processes which shapes the earth surface. All right. And when we talk about the shaping of the earth surface, we have different type of landforms which are produced. Different type of landforms, whether it is mountains, plateaus, or plains, or the other, landforms which are created. So they are created or formed on the surface of the earth because of these geomorphic processes or the earth's shape and size, not size, actually shape, or you can say not exactly shape. The various landforms are shaped according to these geomorphic processes. Now, when we talk about the geomorphic processes, these processes are acting on the Earth's surface, and there are two different type of processes. We have certain processes which actually are there and they act from beneath the Earth's surface. That is that they are the internal forces. Such internal forces are called as the, or they are known as the endogenetic processes or forces. So these are the internal forces. These energies or these forces acts from within the earth and they are the main force behind any landform development or the endogenic geomorphic processes. Then we have the exogenetic forces. These forces are external forces. External forces, that means they are acting on the surface of the earth. All right, on the surface and beneath the surface. That is the major difference between both of them. Endogenic forces will emanate from the within the earth. That is, they are internal forces, and the exogenetic forces, they will act on the surface of the earth. Like we have weathering and erosion. So they act on the surface of the earth. Now, when we talk about the forces which are responsible for both of them, whether it is the exogenetic forces or the endogenetic forces. So the forces which are responsible over here, they are basically different forces. Just a second. Okay. All right. So we have different forces which are responsible, like there is radioactivity in the Earth's core. So the Earth's core, the radioactive minerals which are there, what they do is that they exerts or they emit the heat energy. That heat energy is responsible for deriving the endogenetic forces, that is the internal forces. Then we have plate tectonics that we will be covering in today's session. Then there are certain climatic factors, Earth's rotation, that leads to the weathering and erosion. And also I told you isostasy as well. I told you yesterday, what is isostasy? It is nothing but the balancing force of the earth. The earth balances itself. The earth balances itself. If there is weathering at some place, what happens is that there is the depressions or the sea and the oceans, they get filled and their depth goes on decreasing. So if there is weathering, there is the sea and the oceans, they are becoming shallow. The height is reducing of the mountains, and that is the force that we call as the isostatic force or isostasy. So this isostasy is responsible force, the balancing force of the earth. So all these forces, whether it is radioactivity in the earth's core, whether it is plate tectonics, whether it is climatic factors or the earth's rotation and isostasy, all these forces are responsible for generating endogenetic as well as exogenetic forces. Now, when we talk about the endogenetic forces are basically of two different types. We have two different types of forces, or when we talk about endogenetic forces or when we are talking about the internal forces. So internally, we have two different forces. One acts with sudden force and the another acts with the slow force, or they are slowly generating forces. They are acting very slowly on the earth's surface. See, you do not see a mountain getting built up within a 2 days period or within a 5 days period, all right, or within certain hours. When we are talking about mountain building, it takes huge amount of time. It takes number of millions of years for generating the mountain. In the same manner, if we know, all right, we'll be covering this when we'll be talking about the plate tectonics. So the continents are shifting. We have the continents which are moving. We have plates which are moving. So this is not happening within very short period of time. This is happening over a longer period of time. For millions of years, this is happening. So we have slow forces and we have the sudden forces as well. The slow forces are called as diastrophism. The slow forces or the diastrophism, they act very slowly on the surface of the earth. They act very slow and they are responsible for building up of the different landforms as well. So diastrophism are of two different types. We have the plates which are moving, we have the continents which are moving. So either there could be upliftment or subsidence, or there could be tensile force or the compressional force. All right. So when we have upward force that acts, upward and the downward force, that is the vertical forces, they are basically aperogenetic forces. Aperogenic forces, or you can say they are vertical forces which acts on the surface of the earth from within the surface, or they are the internal forces, and that leads to building of the continents or the oceans. So when we have upward forces, that leads to upliftment of any land surface. So there is upliftment of the land surface, that is because of the upward movement of the that happens within the surface of the earth. All right, so upward movement leads to upliftment, and if there is downward movement, that will lead to subsidence of any place. There would be subsidence. At the same time, when we have horizontal forces, those horizontal forces are called as orogenic forces. Why orogenic? Because they lead to formation of mountains. Oro means mountains. So orogenetic forces or orogeny. When we say orogeny, what is orogeny? Mountain formation. So oro means mountain and genetic means building. So mountain building forces can be of two different types. We have tensile force or tension force, in which the force acts on the opposite direction. That is the tensile force. When you pull something apart, so that is tensile force, and there is compressional force. When two forces they move towards each other, that creates compression, and both of them they lead to formation of the mountains. We'll study the formation of mountains as well, how they have been created or they have been formed. Also, when you understand plate tectonics, you will be able to have all your answers itself, because plate tectonics is the theory on which the complete geomorphology is based. So that is why today's session is very important. All right. If you have missed previous two sessions, it's okay. But for moving ahead, you have to have complete understanding of plate tectonics theory. Now, when there is tensile force, it leads to formation of block mountains or fault mountains. We'll study them, different type of mountains tomorrow, but you will understand them today itself. And then there is compressional force. Compressional force leads to formation of fold mountains like our Himalayas or like Andes and Rockies. So these are the slow forces which are acting very slow. But at the same time, you see certain sudden movements as well. You see earthquakes, you see volcanoes. So earthquakes and volcanoes are result of the sudden forces, and because they bring catastrophe, because they bring destruction, they are also called as catastrophism or catastrophic forces. All right. So we have two different type of endogenetic forces. We have diastrophism and catastrophism. Within diastrophism, we have two again different type of movement, vertical movement and horizontal movement. Vertical movement is called as epirogenic or continent forming movement, where we have upward and downward forces, and the horizontal movement is called as orogenetic or orogenic forces, mountain building forces, where we have two different forces, tensile as well as compressional force. And then we have the sudden movements or the catastrophism or catastrophic forces, which brings destruction on the surface of the earth, and they are very sudden. They happen within short period of time, although it takes a long time to build it up. Volcanoes are not erupting, or the volcanoes, it just not start erupting within certain seconds. All right. It takes longer period of time for the lava to build up. It takes long period of time for the, I'll say, lava to build up or lava to get accumulated, it to move upwards. But when it erupts, it is sudden. The same is with the earthquakes as well. The plates are moving, but again, it takes longer period of time to move for movement of the plates. However, when the earthquake happens, it happens within a very short period of time. All right. So that is why they are called as sudden movements, because they happen, or although they are acting, the forces which are there, they are acting very slow over a very long period of time, but the result is sudden. We see these movements very suddenly on the surface of the earth, and that is why they are clubbed into catastrophic forces. Then comes the exogenetic forces. Exogenetic forces or the external forces. So we have two different type of forces, that is we have weathering and erosion. There is only very simple difference between weathering and erosion. When there is transportation of the debris, when there is transportation of the debris involved, so that is called as erosion. But the simple weathering of the elements of the rocks or the landforms, it is termed as weathering. So weathering could be because of the physical factors, it could be because of the chemical factors, or it can also be because of the biological factors. And in the same way, when we talk about erosion, in erosion, it is important that transportation should be there. So this transportation will happen with the agents of erosion. These are called as agents of erosion because they help in transporting the weathered minerals from one place to the another. So these are the agents of erosion. We can have ice or glaciers to be exact. Then we have river water, river stream, or simply water as well. Then sea, wind, as well as underground water. They helps in transporting the rock debris, and that is what we call as erosion. That is what is known as erosion. So these are the two different forces which are acting on the Earth's surface, shaping the different landforms, endogenetic as well as exogenetic forces. So over here you can see how these forces happen or what these forces do. Endogenetic forces, in endogenetic forces we have diastrophism. Diastrophism, which means the vertical forces. These include all those forces, processes that move, elevate or build up the portion of the earth crust. So we have continent forming forces, that is upward movement. Over here you can see that there is upward movement of the earth surface, or we have the upliftment. We have the upliftment of the earth surface, and at the same time you can see there is downward movement or subsidence that happens because of the epirogenic forces. Then we have orogenic forces that results into formation of mountains, and this is like, for example, we have tensile force that results into formation of block mountains or scarps, and we have compressional forces that leads to formation of fold mountains. In the same manner, we have over here, when there is upward movement, that will result into raising of beaches. There will be raised beaches, elevated wave cuts, terraces, as well as sea caves and fossiliferous beds that will be formed due to the upward movement of the continents. All right. And the example is, we have Koringa near the mouth of Godavari. All right. And also Kaveri Patnam in the Kaveri Delta that have been uplifted. These have been uplifted. That is the example. And when we talk about the downward forces, we have the example of run of Kutch that has subsided. Also, the Andamans and Nicobars, basically they have been isolated from Arakan Yoma or Arakan coast. Where is Arakan coast? It is there in Myanmar. It is there in Myanmar. So when we talk about Arakan Yoma, so Arakan Yoma and the Andaman Nicobar. So when you will see, say it is very important that you also practice map making. All right, you should be able to draw maps, because when you are writing in the mains, for mains writing, if you are writing for geography as a subject, and if you supplement your answers with mapping, if you supplement your answers with flow charts, diagrams, then of course you will fetch more marks. So it is important that you practice mapping as well. So we have Arakan Yoma here. These are the mountains which are located. They are Arakan Yoma, just on the side of the Myanmar. And then we have there is subsidence. The subsidence of these Arakan Yoma, and then over here you will find Andaman and Nicobar. That is Andaman and Nicobar. So between this, we had subsidence. Over here, we had subsidence of these, and that is how you see that the Andamans and Nicobar, they emerge after a period of time. In the same way, Gulf of Mannar and Park Strait, they are very shallow and they have been submerged in geologically recent times. All right. So that is, there is in between we have Tombolo as well. What is Tombolo? Sri Lanka at one point of time, it was along with India. And as Sri Lanka drifted apart, there were piece of continents which were they form the beads in between, and they connect Indian mainland and Sri Lanka. So those continental beads which are in between, which connect an island to the mainland, that is what we call as tombolo. All right. I will study it when we'll be studying the landforms. All right. During that point of time, we will study what is tombolo. So, Gulf of Mannar, Park Strait, Andaman, Nicobar, Run of Kutch, they are the example of the downward force acting on the surface of the earth. Then comes the mountain forming, the movement that is there, or we call them as orogenic movements or orogenic forces. So we have tensile force where the tension, it produces fissures or it creates faults. And when there is upliftment of one of the block, that creates the block mountains. And then we have the compression as well that produces folds leading to formation of fold mountains. Then we have endogenic forces, and the example of endogenic forces are the earthquake and the volcanoes. All right, we have earthquake and volcanoes, which are the important processes. Now, when we talk about these are the endogenic forces. Now, let's talk about the exogenic forces. Exogenic forces, they are basically, or they derive their energy not from inside of the earth, but from the atmosphere. They determine it from the atmosphere, that is by the various climatic factors. And that atmosphere is determined by ultimate energy from the sun. The winds flowing, the rainfall that is occurring in today, right now in various places because of the sun, because of the energy that we get from the sun. So there is a term that we use for the exogenetic forces, that is denudation. Denudation is nothing but it is the wearing and tearing away of the earth or the landforms, which causes a general lowering and leveling out of the surface. There are different agents of denudation, that is we have air, water, ice, wave action, chemical reactions and gravity that leads to this denudation. So we have different phases of denudation. We have weathering, which is simply wearing and tearing down of the rock debris. Then we have mass movements where the complete mass of sand, rocks or even landform, it moves. We have also erosion, which includes transportation, and we have the deposition as well, where we have different landforms have been created. So the different landforms, whatever landform that you see, they have been created either because of the erosion or because of the deposition. All right. So these are certain terms that you have to remember. All right. We have flow. What is flow? When a part of the landform, it is moving because of the gravity. All right. And the speed is very slow, that will be flow. Then there is topple, there is slump. Slump is when it gets, in a arc like manner. And then we have slide, like we have landslides, debris slide. So over here we have fast moving objects, whether it is land or it is debris, rocks. When they are fast moving, they are sliding. And then we have creep as well, where there will be, very large mass of the soil that will come and it will influx into the lower areas. And there is also falling of the rocks. All right. The rocks or the debris that will fall because of the gravity. All these motions are because of the gravity. And that is what we call as mass wasting or mass movement. This mass movement, it may be because of the wetness. There can be wetness when there is river involved or water involved. Like, these days, you must have heard in the news that there had been landslides in Kullu and the other places. All right. we had lots of landslides. Creep is when it moves slowly. I'll let you know what is creep. All right. When there is movement of soil or there is movement of rocks very slow. So that is what we call as creep. All right. Hari. So there could be wetness in the region. All right. So like I told you that in Uttarakhand and Himachal, there have been lots of rainfall in the recent times, in recent days. So what has happened is that because of that wetness, we had landslides that happened there. Then it could be dry as well. Dry means that there is less or completely dry region, like rocks are there, so they will also fall because of the gravity. All right, so they are dry, but they are falling downwards. In the same manner, when we are talking about the movement or the pace of the flow, so the pace can be, it can be fast. The pace of the flow can be fast or it could be slow. So depending upon how the things are happening, or depending upon how fast or how slow they are happening, whether the material is dry or that is wet, we can have different types of mass wasting. We can have seasonal soil creep. We can have talus creep. Talus is also soil creep, or we could have rock slide. All right. So rock slide, landslide, over here you will find that there is a fast movement. But in the form of soil creep or talus creep, the movement will be very slow. Slowly and slowly, they will come downwards. Then, if it is slow as well as there is lot or it is saturated soil. When it is dry soil, it will lead to soil creep. But when we have saturated soil, it is neither too wet, neither too dry. It is saturated with water, that will lead to solifluction. We'll have lot of mudslide that will happen. All right, solifluction. Then there is earth flow as well as mud flow. Earth flow and mud flow happens when we have more of wetness that results into falling of the debris along the gravitational or because of the gravity that leads to mud flow and earth flows. So that is how we see that there are different mass wasting. Over here you can see we have solifluction and creep. Solifluction and creep will be very slow. That will be slow, and you can see over here the soil will creep downwards. All these processes happens because of the gravity. They will be following the slope. They will be coming downwards. So when there is slow movement of soil, that is called as soil creep. In the same manner, when we have a bigger area of soil that creeps, that is called as solifluction. Solifluction happens when we have saturated soil. Then we have slumping. You can see this is some slumping. Slumping happens when there is a curved or arc that is formed. So over here you can see that there is a arc-like movement, and that arc-like movement is called as slumping. Then we have lahars and mud flows. We have lahars and mud flows. We have debris flows. And when we have rocks which slide, that is called as rock slide, or when there is complete land along with the mud, rock that comes downwards, that results into landslide. And sometimes when it is very fast, that also brings the rock avalanche. So that is the mass wasting, where we have a bigger mass, bigger chunk of rocks, debris, mud that moves downwards on the due to the gravity. That is what we call as we call them as the mass wasting. All right. Then comes the weathering. Weathering, like I said, it is just the wearing and tearing down of the rock materials. Now, weathering is action that is or that happens because of the weather and climate. And weathering, it could be of three different types. What are the three different types? We can have chemical weathering that happens because of the chemical reaction. A chemical reaction occurs within the rock and it leads to dissolving the rock and forming new substances. Like for example, limestone is dissolved by rainwater. So where we have limestones, they are dissolved by rainwater, it forms calcium carbonate, and then we have the caves which are formed. We have cave formation. Then we have mechanical weathering that happens because of the physical factors. Physical factors like heat and temperature, or we have pressure as well. Alright, so when we have heat, temperature, or the pressure playing a very large role in the weathering, that would be called as mechanical weathering, and there is no chemical change like freeze thaw action. What is freeze thaw action? There is when there are cracks in the rocks. What will happen? The water will fill the cracks, and then when it will freeze, it will expand, it will lead to breaking of the rock. So that is mechanical weathering, and then we have biological weathering, which happens due to the action of plant, animals, or even human. So that is what we call as biological weathering. Now, when we have chemical weathering, it is because of the chemical reaction. It could be of three different types. We have carbonation. Carbonation happens because of the carbon dioxide. So, when we have carbon dioxide and water, they form the carbonic acid, which is a weak acid, and it dissolves the rock, and that is what we call as carbonation. Then we have hydration, where the minerals take up the water and expand. So this induces the stress and results into breaking down of the rocks. Then we have redox or reduction and oxidation. Here we have the mineral which combines with oxygen and then they form oxides or hydroxides. So when we have the oxidized minerals, and they are placed in the environment where oxygen is absent, reduction takes place, and due to this there are different chemical changes that happens within the rock surface, and that is what we call as redox reactions as well. Like for example, you must have seen rust, iron rust, that is because of the iron oxide. So red color of iron, when it is reduced, so it becomes greenish or bluish gray due to reduction where we do not have the oxygen. Then there is physical or chemical weathering. It is because of the heat or pressure. So where we have heat or pressure involved, that results into breaking down of the rocks, and that is what we call as the physical or mechanical weathering. It could be exfoliation. Exfoliation is which happens layer by layer. You must have seen onion. You must have seen onion. And onion is how onion is, the structure is that there is one layer, then another layer, then another layer. So when you will be peeling the onion layer by layer, that you can call as exfoliation. So what is exfoliation? Where layer by layer weathering happens, that is called as the exfoliation. Then there could be block separation. A particular block will separate. There could be granular disintegration, which happens due to the grains getting disintegrated, the grains in the rock particles. There could be mass wasting. There could be shattering frost or wedging salt weathering as well. So the frost, like I said, when the water, it gets into the crack, it gets, expanded when it is frozen, and later on it again contracts. Again the crack will widen, again more water will get filled up, and then again it will expand, and that will result into breaking down of the rock particles. So these are the different forms of physical or mechanical weathering. And the third type of weathering is biological weathering. So biological weathering is because of the bio agents, bioagents, that is plants, animals, that will result into breaking down of larger rocks into smaller rock fragments, and that is what we call as the biological weathering. Like for example, burrowing and wedging. So we have different animals which burrow themselves inside the earth's surface. So what they will do is they will help in exposing the new surfaces to chemical attack or chemical weathering, and then also they will assist in the penetration of moisture and air deep inside, that will result into weathering. In the same manner, there would be decaying plant and animal matter, that is we have humus. So humus, again there is organic changes that happens. We have humic and carbonic and other acids which are produced due to dead and decaying animal and plant remains, which brings out the weathering of the larger rocks. Algae, which utilize mineral nutrients for growth and it helps in concentration of iron and manganese oxides, also brings the chemical changes and disintegrate the rocks. And when the plant roots, they move deep inside the earth surface, they also mechanically break the rock surfaces. So that is how we have different forms of weathering that happens. All right. Now, any doubt up to now? Any doubt, anyone? Any doubts? Volcanic mountains, are they due to orogenic forces? Actually, volcanic mountains are because of the volcanic eruption. They are not due to orogenic forces. Orogenic forces leads to building up of block and the fold mountains, Ritik. All right. Actually, when we talk about the volcanic eruption we will study when we'll be studying the volcanoes also. So volcanic eruption could be of two different types. It could be a fissure eruption. Generally, during the fissure eruptions, the volcanic mountains are not produced. All right. During fissure eruption, like we see when we see the when we have the mid-Atlantic ridges and mid-oceanic ridges. So there we have the fissure eruption. Like we have the Great Rift Valley, there is a fissure eruption. So some of the mountains or some of the volcanoes, when there is a point eruption, so some of the volcanoes or volcanic eruption, it can take shape of the mountains and then they are called as volcanic mountains. So volcanic mountains are not due to orogenic forces. Orogenic forces leads to building up of fold as well as block mountains. Okay, Ritik? Any other doubts? Any other doubts, anyone? All right. So now let's move to plate tectonics. Let's understand the plate tectonics. It is very important to understand this concept. So if you have any doubts, after we read the plate tectonics, if there is any doubt, please get it cleared in the class itself. Because it is said that some concepts you understand only in the one go. All right. This is one such concept. You will understand it in one go and then it will remain in your brain throughout your life. All right. So now when we talk about the plate tectonics, it started, or you can say that, there are different tectonic processes and that lead to, or important concepts that lead to formation of the plate tectonics theory. The first such theory was continental drift theory given by Alfred Wegener in 1912. Later on, there was polar wandering theory, then seafloor spreading theory by Harry Hess, then convection current theory by Arthur Holmes, and all these combinedly, continental drift theory, polar wandering, seafloor theory, convectional current theory, that lead to formation of the plate tectonics theory. Now, let's understand continental drift theory first. When we are talking about continental drift theory, it simply says, like the name itself, the continents drifted. This theory, it says that there was one large landmass or a supercontinent. It says there was a supercontinent which was called Pangaea. So Pangaea was a supercontinent. It was a large landmass or a supercontinent called Pangaea, and it was surrounded by Panthalassa. Panthalassa was a super ocean which surrounded the Pangaea. All right, when the earth was formed. This theory was given by Alfred Wegener in his book The Origin of Continent and Oceans. He was German meteorologist and he did lots of surveys to prove his theory. Now he says that what happened was that this Pangaea, it got divided into two different parts. One was northern part. The northern part he called it as the Laurasia or Laurentia, or it is also known as Angara land. There are three different words. Just a second. I'll use different pen. It was called as Laurentia, Laurasia, or Angara land by Wegener. And then there was southern part or the southern portion. This was Laurentia, Laurasia, or also called as Angara land. All right. Then he said that this complete Pangaea, it got divided into two parts. And when it got divided into two parts, what will happen? A part of the ocean will fill up the space that was in between. So he said that due to this, Tethys Sea appeared. Due to this, what happened? Tethys Sea appeared between Laurentia and Gondwana land. And this Tethys Sea divided the Pangaea into the northern part and the southern part. Now, my question is, in which form you will find or in which type of sea, name that sea which is remnant of Tethys Sea. Can you name the sea that is remnant of Tethys Sea that you will see today? So, Tethys Sea, you can find remnant of Tethys Sea. Remnant is Mediterranean Sea. The Mediterranean Sea that you see today is actually the remaining portion of the Tethys Sea. All right. Okay. So, Tethys Sea occurred or Tethys Sea, it appeared between Laurentia or Laurasia and Gondwana land. Later on, he said that the Gondwana land, it broke into 5 different parts, and Laurasia, it broke into 2 different landmass. So he had 2 assumptions that the Sial floats over Sima, or the continents, they float over oceans. Continents, they float over oceans. And there were now, he said that now what happened was that when these breaks or the breaking of the Laurasia and the Gondwana land happened, so they started drifting from each other, apart from each other. And then it was asked, because for the drift, there has to be certain kind of force that should be there. So he said there are certain forces which led to this drift. He said these forces are tidal force, the same tidal force that leads to formation of tides in the oceans, the gravitational pull of sun and the moon. All right, tidal forces. He said there is buoyancy forces because what is happening is that the continents are floating on the oceans. So when the continents are floating on the oceans, basically there is a buoyant force that is acting on it. So there have been certain assumptions that he took. He said there are tidal forces, buoyancy forces. What these forces are doing, tidal force is deriving these continents towards west. He said there are two directions where the continents are drifting. It is drifting towards west because of the tidal force, and it is drifting towards the equator because of the buoyant force. He said there are two directional movement of these continents towards west and towards equator. So that was given, or this continental drift theory was given by Alfred Wegener. So over here you can see that initially there was Pangaea, a single continent or a supercontinent. 225 million years ago. Then what happened was that it broke down into two different parts, Laurasia as well as Gondwana land. And there was Tethys Sea that emerged in between. I told you the remnant of this Tethys Sea you can see in the form of Mediterranean Sea. The Laurasia again got divided into two parts. What are the two parts? North America and Eurasia. North America and Eurasia. Over here you have to see that Eurasia does not include India. So they were part of Laurasia, both of them, North America and Eurasia. They were part of Laurasia, and the Gondwana land was divided, or it got split into 5 different parts. According to Wegener, that is South America, then we have Africa, also India, Australia and Antarctica about 100 million years ago, and then they drifted leading to the present Earth, or the where we find these continents today. So this was the hypothesis given by Alfred Wegener. All right, you can see over here there was Pangaea. Now what happened was that started moving. Pangaea started moving. All right, the Pangaea, it got divided into Laurasia and Gondwana. Then again they moved, and you can see how India was, absorbed, or India drifted towards Eurasia, and that is how we have the present Earth that we see today. Now, there had been certain, like I said, he was a German meteorologist. So he went for a whole world tour. He went for a whole world tour and he gathered evidences in support of his theories or his hypothesis, continental drift theory. He saw that that when we talk about the ocean, when we talk about the continents, so the continents can fit together easily. There is apparent affinity of the physical features, and this is called as jigsaw fit of the continents. So these continents, like we have South America and Africa, so they fit together easily. They can be pulled together like piece of puzzle, and they can be fit together. That is called as jigsaw fit or apparent affinity of the physical features of the continents. Also, he found gold placer deposits. Gold placer deposits which are there in Ghana, they came from Brazilian plateau. All right, and that could happen only when both of them were connected at certain point of time. Then only the placer deposits which are there in Ghana, they could come from the Brazilian plateau when they were together. Then there are tillite deposits. The tillite deposits or the ice during when there is ice age. So what happens is during that ice age there were tillite deposits that got deposited, and he found those sediments, those Gondwana sediments in the Gondwana region, whether it is in India, whether it is Africa, Falkland, Madagascar, Antarctica, and as well as Australia. Now, India is in tropical or subtropical region. So it is not possible to have tellite deposits. All right, unless and until they were together placed near the polar regions. So he said that because of the tellite deposits which are found in the Gondwana region, at one point of time they were together and they were near the South Pole. Then there were rocks of the same age that he found across the oceans, on the both sides of the oceans. So he found that there is a belt of ancient rocks of about 2000 million years old, that is from Brazil coast, which matches exactly to the opposite coast on the Western Africa. There was distribution of fossils as well. There were fossils of freshwater reptile that were found in South Africa and Brazil, and also polar wandering, that the poles have wandered. Which poles? Not the geographical poles, but the magnetic poles of the earth have wandered, or they have shifted their place constantly. And it could be only explained when the continents might have shifted. And then there is botanical evidences also. The fossil of Glossopteris has been found in all of the Gondwana continents. So all these evidences he put forward, and of course, by seeing these evidences, it looks like he was telling the truth. But this theory majorly lacked the forces. He could not explain properly the force behind this drifting. But yes, his evidences points to a certain thing, that these continents might have been together at one point of time. So there is apparent affinity of the physical features. As you can see that the bulge of Brazil over here, we have Brazil. It seems to fit into Gulf of Guinea. So over here we have Brazil. This is Brazil and this is Gulf of Guinea. So it fits easily over here. In the same manner, Greenland, it fits well into Ellesmere Island and Baffin Islands of the Canada. In the same manner, the west coast of India, along with the west coast of India, Madagascar and Africa, they seem to have been joined. So when you join these pieces of the different continents, it looks like they fit together just like a jigsaw puzzle, and that is why it is also called as jigsaw fit. Then there were botanical evidences. There was presence of Glossopteris. Glossopteris is a fern that was found in all of the southern continents. It is a vegetation which was found in Carboniferous rocks in India, Australia, even Antarctica and South Africa, Falkland Islands and Antarctica as well. In the same manner, there were different fossil evidences of the Triassic therapsid, that is Lestosaurus, fossil remains of freshwater reptile Mesosaurus, which was found in South America and Africa, as well as fossil remains of Cygnognathus that was found in the South America and Africa. So there were botanical evidences also that he put forward. Along with this, there was observation that they were lemurs. All right, the lemurs, they occur in India, Madagascar and Africa. So that is why some of the geographers, they also called this landmass, India, Madagascar and Africa, as Lemuria. Then Mesosaurus, like I said, they occurred between the places of South America and Africa. The fossils were found, the skeletons were found, and there is 4,800 kilometer distance between both of them. This is freshwater reptile. It cannot swim across the ocean and reach the another continent. That means that South America and Africa, they were linked together. Then there were stelite deposits. The deposits of the glaciers, they were found in the Gondwana continents, or the continents that were part of the Gondwana. In India, Africa, Madagascar, Antarctica, and Australia, which were previously part of the Gondwana. So that means at certain point of time they were joined together. Placer deposits were found in Ghana coast. Now Ghana coast, but the source or the veins, gold bearing veins, they were found in Brazil. So of course, if there are gold deposits in Ghana, they have been derived from the Brazilian plateau, and again this also leads us to believe that the continents were stick together at one point of time, and then there are rocks of the same ages between different belts or uh, different coast of the oceans, opposite ends of the Atlantic Ocean that were seen, and also matching mountain ranges. All these evidences points out that yes, at some point of time these continents were together. But there are certain drawbacks to this continental theory and continental drift theory, and that is why this continental drift theory was discarded, or it was discarded because of the lack of different things. Because Wegener failed to explain why this drift only began in the Mesozoic era and not before Mesozoic era. He was not able to explain this. Also, this theory doesn't consider oceans. It just considers continents, that the continents were drifting. But now we know that the Atlantic Ocean is getting widened. So it did not consider, or it doesn't consider oceans. Proof were dependent on the assumptions. The two assumptions that he made while forming this theory. And these assumptions are very generalistic. The tidal force is not that much force that it could drive the ocean towards the western side. In the same way, forces like buoyancy, tidal currents, and gravity, they are too weak to move the continents. And now we know that the modern theories have accepted the existence of Pangea, but now they have given a very different explanation to the causes of drift. And that is why this continental drift theory was not accepted at that point of time. But now it led to formation of plate tectonics theory. So therefore, it is very important theory at today's world. Now you can see this type of question you can find in your exam. Which of the following phenomena might have influenced the evolution of organisms? So evolution of organisms, we have continental drift and glacial cycles. So what would be your answer? Give me the answer. All right. Let me see if you are understanding things as well. Why not both 1 and 2? Yesterday we have discussed about the geological time scale. We discussed about the geological time scale. We discussed about 5 ice ages that were there, right, Sonali? And during those 5 ice ages, what happened? There was evolution as well. We evolved with the geological time scale. So, of course, when we are talking about evolution of the organism, might have influenced, yes, continental drift has influenced, because at one point of time, the continents have drifted, leading to changes in the climate and also glacial cycles. That is, answer would be both 1 and 2. Okay, that would be the answer. All right. Now, next question about continental drift theory. Consider the following statement regarding continental drift theory. I want every one of you to give the answer to this one. The theory was proposed by Alfred Wegener in early 20th century. It suggests that continents have remained in their current position since the Earth's formation. The presence of similar fossils on continents separated by oceans supports this theory. So what will be the answer? Give me the answer. Give me the answer for this. Very good. Triple dots. All right. So what would be the answer? We are talking about continental drift theory, and continental drift theory is saying that the continents have drifted Second statement is, it suggests that continents have remained in their current positions. No, they have not remained in their current positions, but they have drifted, and that is why statement 2 is incorrect, but the rest of the statement are true. So answer would be 1 and 3, right? That would be B. Very good, Sonali. And Tawfiq, very good. Okay. So such type of questions you may find in your answer, in your question exam. All right, now this is for, you have to write the answer. You can submit it on the WhatsApp group as well. When you have written it, what do you understand by the theory of continental drift? Discuss the prominent evidences in its support. All right. Now, let's talk about the convectional current theory. This convectional current theory was given by Arthur Holmes. It was given by Arthur Holmes. He was a British geologist, and he said that there is possibility of convection currents in the mantle. What are convection currents? There are three methods of heating or three ways of heating or heat transfer. Three ways of heat transfer. You must have read this or you must know this from physics. In physics, in thermodynamics, we speak about the different ways how the heat can transfer. The heat transfer through conduction. It transfers through conduction. What is conduction? When two objects are closely placed together. All right, that is conduction. Conduction is generally seen in solids. In solids, you'll find that the heat transfer is done when two objects are placed together. All right. The second way of heat transfer is convection. Convection happens in fluids. Fluids, that is gases and liquids. In fluids, we have convection. What happens in convection is that when you heat water, what happens? The lower layer gets heated and it moves upwards. And the colder layer, it comes downwards. So there is a convectional current or currents that flows when you are heating gas or liquid, and that is the way of transfer, heat transfer in the fluids. Then comes radiation. Radiation happens in vacuum, like we have solar radiation. So sun rays, they travel through vacuum, reaches the earth's surface, and then they heat. So radiation can happen through vacuum. Although radiation can happen with conduction and convection as well. Now, Arthur Holmes, he discussed the possibility that there could be convectional currents in the mantle. Because in the mantle, we know now that there is a layer that is in, it is in what? It is in, you can say, plastic state. And it is the, when he saw that there are volcanic eruptions, there is liquid magma that is coming outside. So he discussed that there is a possibility of the convection currents which are there in the mantle. And these currents are basically because of the heat generated by the radioactive elements. So we have different radioactive elements there. They causes the thermal differences, and because of these thermal differences in the mantle, convective currents or convection currents, they start following or flowing. Now, when they have these rising limbs, over here you can see that we have rising limbs. So these rising limbs, they meet the oceanic ridges. We have oceanic ridge where we have the sea floor divergence. All right. So rising limbs of these currents, they meet, and thus we have the ridges which are formed on the sea floor because of the divergence. However, when we are talking about the falling limbs, they meet, and because of this, trenches are formed. Trenches are deep V-shaped valleys in the oceans. All right, so there are very deep valleys which are created in the oceans, and they are because of the convergence of these convective currents. He said that this is how we have the movement that can happen, which was earlier suggested by Alfred Wegener. Or he said this may be reason why we have continental drift. So this theory, convection current theory, was given by Alfred Wegener in 1930s. It was in 1930s that he gave this theory. So over here you can see how this convective current theory happens or it works. We have the convection currents. The convection currents, they move upwards and then they diverge. When they diverge, they create the oceanic ridges. And also when we have the falling limbs, they converge together and they lead to creation of the trenches. That is how the convection current theory works, or it explains why we have movement of the continents on the earth. All right, here you can see we have the falling limbs leading to formation of the trenches. The deepest trench on the earth is Mariana Trench, which has a depth of 11022 meters, or it is more than 11 kilometers. That is how we have the Mariana Trench. It is the deepest trench that you can find. All right, now give me the answer to this one. With reference to convectional current theory, consider the following statement. It was proposed by Arthur Holmes as a mechanism for moving or movement of continents. The theory suggests that heat from the Earth's core creates convection currents in the mantle. Third, convection currents in the mantle are responsible for formation of oceanic ridges and trenches. What would be the answer? Comment your answers in the chat box. Let me know what should be the answer. Read the statements very carefully. Whenever you are answering the questions based on statements, it is very important to read the statements and understand the statements. I have told you just now that this theory suggests that heat not from the earth core. It says heat from the earth's core. Ain't it wrong? Because this theory suggests that the heat is inside the mantle. And it is because of the radioactive substances. We have the radioactive substances or elements that causes this thermal differences. So over here, the second statement is incorrect, but the rest are true. The answer would be 1 and 3. That is C will be the right answer. Very good, Ritik and Ritisha. All right. Okay. Now comes polar wandering. What is polar wandering? Polar wandering is nothing but it is the shifting of the magnetic poles. So we have shifting of the different poles, magnetic poles from one place to the another. And this was mapped. Now what happened was, now if the continents are fixed, then the pole will move with relative to that continent. All right. If the poles are getting shifted, they will move relative to the continent from A to B to C to D. All right. If the continents would have been stationary, they would have been fixed. But if the pole is fixed, then the continent, they must have drifted related to the pole. However, when this was seen from North America, the path was different. When the polar wandering was seen from the Europe, the path was different. So apparent polar wanderer path of North America, it is not same as that of Europe or Africa. So this path was different. Now the path could be different only when the continents must also have drifted. All right, along with the poles. If the continent are fixed, then the pole is only wandering. All right. If the pole is fixed, then the continents may be wandering. But when seen from different continents, the path was different. Over here, you can see for the North America, for Europe, as well as for Africa. This path was different. For every continent, that means that both pole as well as the continents are also wandering. All right. So that is how polar wandering gives us an idea that the continents have shifted over a period of time. Then comes the seafloor spreading. Seafloor spreading this theory was given by Harry Hess. He was professor of geology and he was studying Atlantic Ocean. Actually, he was studying the Atlantic Ocean. And when he was studying the Atlantic Ocean, he saw that the Atlantic Ocean is getting widened. Now, because before there was convective current theory, polar wandering theory also came, and continental drift theory was there. So he said that there is basaltic magma. This basaltic magma, it rises from the fractures. And then later on it cools down on the ocean floor. So this forms a new sea floor where in the middle. And the earlier sea floor, what happens is it migrates to the outer edges. So newly formed sea floor moves away from the ridge, and this place or its place is taken by even newer sea floor, and this gets on repeating. So with time, older rocks are found away from the ridge and newer rocks are found near the ridge. So he said that what is happening is that the sea floor is getting spreaded, or the Atlantic Ocean is getting spreaded. Now, for this, he actually conducted certain studies. He started seeing the magnetism in the rocks. That is what we call as paleomagnetism. What is paleomagnetism? It is recording of the Earth's magnetic field in the rocks. So he started measuring these magnetic fields as well. Now, whenever the rock is formed, if it will have the magnetic materials, all right, or like it will be, primarily there would be iron in the rock. So what will happen is that it will align, or the magnetic property of that rock will align itself in the direction of the magnetic field. Now, I told you that there is magnetic reversal. Whenever there is magnetic reversal, the polarity of the earth, it gets reversed. North pole, magnetic north pole becomes south pole, and magnetic south pole becomes the north pole. So there are magnetic field reversal, and through this paleomagnetism, he recorded that with the rocks which were formed at the same time period, they were found on the same distance from the ridge because of this paleomagnetism. All right. Over here, you can see that this is how, like for example, if I'm talking about the normal magnetic field. So suppose these rocks have, this is north and this is south polarity. And again, over here, you'll find north and south polarity. As he moved away from the ridge, he found that suppose if this rock has a opposite polarity, south and north, so he saw that at the considerable and the same distance, he found the same type of rocks formed in the same ages with the reversed polarity. There was reverse polarity and the distance was also same. So that is how he said that the sea floor is spreading and newer crust is getting formed near the ridge, and the older rocks are pushed towards the outer regions. All right. So paleomagnetism, nature of rocks, as well as seismic activity gave the evidence for the seafloor spreading. Now, we have different theories up to now. All right, we have different theories up to now. That is, we have the, we have continental drift theory, we have polar wandering theory, we have convective current theory, and seafloor spreading theory. Now, combining all these four theories, what happened was that there were two scientists. In fact, there were three scientists. The third one was later on who propounded the plate tectonics theory. All right, now on the basis of seafloor spreading, consider following statements. First, it was proposed by Harry Hess to explain the movement of oceanic plates. Second, the theory suggests that new crust is formed at mid-oceanic ridges and destroyed at oceanic trenches. Third, the discovery of alternating magnetic stripes on the oceanic floor provided strong evidence to this theory. So what will be the answer for this question? Attempt, try to attempt, because if you will not try to attempt such type of questions, you will not be able to attempt these questions in your exam as well. All right, so everyone who is present in the class, they should attempt and they should try to attempt. Very good, Ritik. The answer would be correct. It is all the three are correct statements. Answer would be 1, 2 and 3. All right. Now, another question. With reference, which of the following evidences supported the sea floor spreading theory? First, age of oceanic rocks increase as we move away from mid-oceanic ridges. Presence of symmetrical magnetic stripes on either side of mid-oceanic ridges. Third, existence of deep sea trenches where oceanic crust is subducted. Fourth, continental crust is older than the oceanic crust. So you have to tell what will be the correct answer, which of the following evidences they support sea floor spreading theory. What will be the answer? No, Ritik. This time it is incorrect. See, how could continental crust could be older when we have newer crust that is forming at the oceanic crust? What seafloor spreading theory says? That the new crust is getting formed at the oceanic ridges. So we have the continental crust is older? No. Oceanic crust is, older than oceanic crust. Yes. Continental crust is older. I thought it is newer. Yes, continental crust is older than the oceanic crust because new crust is getting formed at the oceanic ridges. So therefore, when we talk about fourth, that will be right. So all the four would be the right answers. All right. It will be D. I'm sorry, Ritik, you had the right answer. Yes, it will be D. Now, next, when we talk about the plate tectonics, it is Mackenzie, Parker, and later on Morgan. All right. Mackenzie, Dan Mackenzie, Robert L. Parker, and Morgan. They all gave this theory. Morgan actually later on modified this theory a bit. So we usually use all the three names when we are describing plate tectonics. According to plate tectonics, our complete lithosphere. What is Earth's lithosphere? The Earth's lithosphere is 100 kilometer wide, right? I told you it comprises of the crust and upper part of mantle, that is solid. So plate tectonics says that our complete Earth is divided or broken into distinct plates or tectonic plates. These plates are called as tectonic plates. And these tectonic plates are basically floating on ductile or plastic layer that is called as asthenosphere. Asthenosphere, again, it is part of the upper mantle. So the crust and the top mantle thickness from 5 to 100 kilometer, that or up to 200 kilometer for the continental areas, that is the tectonic plates. These are the tectonic plates or the width of the tectonic plates that you will see. These tectonic plates are moving on asthenosphere and that creates a motion. and that is why it is called as plate tectonics. Tectonics means movement of these plates. All right. So all three, Mackenzie, Parker, and Morgan, led to formation of this particular theory. Now, there are two different type of plates. We have oceanic plates. Oceanic plates, they contain sema or sematic crust, that is silica and magnesium. And the continental plates, they contain sialic or silica and aluminium material. But at the same time, oceanic plates, because they have sema, so they are denser. They are denser as compared to the continental plates. The continental plates have Sial, and that is why they are thicker, but they are lighter. They are thicker, but they are lighter. The lithospheric plates or the tectonic plates, they vary. We have minor plates as well. We have major plates as well. We have continental plates, which are comprised of only continent. Two, we have oceanic plates like Pacific plate, and then we have oceanic and continental plates as well. All right. So over here, you can see how plate tectonics have shaped the complete Earth. How these plates have migrated, how these plates have moved and led to formation of the modern world that we see today, or the placement of the continents that we see today. So slowly and slowly these plates, they migrate, they move on the asthenosphere, leading to formation of the continents that we see at present. That is how the continents or the different continents were formed as you see today. So Mackenzie and Parker and Morgan, they used all the previous theories, that is continental drift theory, the convective current theory, seafloor spreading as well, and the polar wandering, and they gave this plate tectonics theory. So here we have major and minor plates. How many major plates are there? There are total 7 major plates. How many major plates? 7 major plates are there. So which are the major plates? We have North American plate, we have South American plate, then we have African plate, we have Eurasian plate, then we have Indo-Australian plate. This is a combined plate. We have Indo-Australian plate, we have Pacific plate, and we have Antarctic plate. So these 7 plates are the major plates. North American plate, along with it South American plate, African plate, Indo-Australian plate. This is single plate. All right. Indo-Australian plate, Pacific plate, Eurasian plate, and Antarctic plate. So how many plates are total? Major plates, 7 major plates. And there are 21 minor plates. There are 21 minor plates, and over here you can see the minor plates as well. All right, you can see the minor plates as well. When we are talking about minor plates, we have Juan de Fuca plate. All right, it is a minor plate. Cocos plate. Please note their region also, where they are located, because at some point of time you will find such questions in your UPSC exam as well. All right, then we have Nazca plate, which is the largest of the minor plates. Then we have Caribbean plate over here. This is Caribbean plate. All right, where we have the Caribbean Sea, West Indies Islands. All right, we have Easter plate, Juan Fernandez plate over here. Then you can see Scotia plate. All right, then in the minor plates you will see Arabian plate. It is completely continental plate, Arabian plate. All right, and you can see that Arabia or Arabian plate, it was not part of the Eurasia before, just like Indian plate was not part of Eurasia. In the same manner, you can see over here Burma plate, Philippines plate, that is there. So these are some of the minor plates that you can see. So the complete Earth is divided into 7 major and 21 minor plates. Complete Earth. Now, these plates are in motion with respect to each other. This motion creates different boundaries. When we were talking about the convective currents. So convective currents, we have the rising and we have the rising limbs that meet or merge together. So when they meet or merge together, they make convergent boundary. Converge when we have the two different convective currents, they are converging, and as a result, there are two different plates which converge towards each other, that creates convergent boundary. Then we have divergent boundary, where we have the convective currents, they are moving in opposite direction. That creates divergent boundary. And at some plates, what happens is that the currents, they move or they slide past each other. They do not interact head on, or they do not move from each other head on, but what they do is they slide past, and that creates a transform edge or transform boundary. So there are three ways in which the plates, they interact with each other. Over here, you can see the interaction of the plates, how they are interacting. We have divergent plate boundary, we have convergent plate boundary, and transform plate boundary as well. In the convergent plates, there are two plates which are moving towards each other. One plate will subside, and what will happen is, when they will subside, there would be formation of different landforms. Just like continental plate subsided, that created Himalayas. All right. When there would be continental to oceanic plate, that will create volcanoes, and it will also create the volcanic mountains as we see in the form of Andes and Rockies. All right. That happens when we have continental to oceanic plate interaction. So that leads to formation of volcanoes. All right. So there is lithosphere which goes deep inside, and a part of it gets molten because there is heat inside the Earth's surface, and that creates the volcanic eruption. Then there are divergent plates that move from each other, or they move apart, and that creates the divergent boundaries. This creates ridges. This creates rift valleys. This creates also the volcanoes. So we have the mid-oceanic ridges which have been created because of the divergent plates, because we have the divergent plates which are moving away from each other. And as they move away from each other, there would be a long ridge or long fissure that would be created. Again, the magma will come out, and that will create rift valleys, like we have African Rift Valley. Then we have the transform plate boundaries, where the plates move or they slide past each other. When they slide past each other, they do not create volcanoes, but they do have impact on the earthquake. So for any of the plates, whenever the plate are moving, so I told you about isostasy. All right, what is isostasy? So San Andreas fault is a transform boundary, as you can see over here. All right. Now, when we are talking about the isostasy, in all the plate boundaries, whether it is divergent plate boundary, whether it is convergent plate boundary, or whether it is transform plate boundary, the Earth's rocks are elastic. So what happens if the plate is moving downwards? It will try to come back to its original place. In the same manner, if a plate is moving opposite direction, it will again come back to its own place. And if it is sliding past, it will again come back to its own place because of the isostatic adjustments or the elasticity of the rocks. And what will happen? There would be disturbance to the earth crust in any of the plate boundary. So if there is movement of any of the plate boundary, that is bound to give rise to the earthquakes, right? And volcanic eruption will happen on divergent boundary and convergent boundary, but not on the transform plate boundaries. So what happens when we have divergent plate boundary? So the first thing is that there is warping of the lithosphere, beginning of the formation of divergent plate boundary. Then the first step is that there is, first there is movement in the opposite direction, then there is formation of the rift valley. There would be a rift valley that would be created, just like East African rift valley is there. Then slowly and slowly it will get widened. When it will get widened, that will lead to formation of a linear or a narrow sea. Like for example, we have Red Sea. It is at the same stage. So Red Sea was also created due to the divergent boundary. Then later on, it will get widened and it will lead to formation of an oceanic ridge. Like for example, when we talk about the Atlantic Ocean, it has been created in this manner. So that is how divergent plate boundary works. The plate diverge or they move away from each other. Mid-oceanic ridges, like for example, we have Mid-Atlantic Ridge, is created in the same manner. Now, the question may be asked that which of the following is the longest mountain system of the world? Please remember, when we are talking about longest mountain system or mountain range, actually Mid-Atlantic Ridge consists of the volcanic mountain. It is the longest mountain system in world. But if it is asked in your examination, which of the following is the longest continental mountain system? Longest continental. Please remember, it is very important to read down the fine prints when you are appearing for UPSC examination. Because what happens is, just a single word changes the complete meaning of the sentence. If it is asked longest continental mountain system in the world, so longest continental mountain is Andes. Longest continental, if it has been specifically asked, longest continental mountain range or system in world, so then your answer will not be Mid-Atlantic Ridge, it will be Andes, which are located in South America. All right. Now, so what happens is that Mid-Atlantic Ridge, Mid-Oceanic ridges are formed due to this kind of interaction, and also divergent edges are where we have the formation of earth crust. There are new earth crusts that are formed at the edges. Also, we have the volcanic earth which are formed. That is why divergent edges or divergent plates are also called as constructive plate margins, because there is construction that is happening over there. Construction of a new crust. So they are called as constructive plate margins, because at the margins of these plates you will find new crust getting formed. All right. So over here you can see that there are the rift valley that is created because of the divergence of the plates. We have such divergence of the plates that you will see over here. We have the Arabian plate and the Somalian plate. Then also Somalian plate and East African or African plate, they are getting diverged. Indian plate and Somalia plate as well. So over here you can see, and then there is Tanzanian craton. So at this Tanzanian craton and East African Rift Valley system, you will find lots of volcanoes, lots of lakes which have been formed. All right, right from here, from the Red Sea, and from here, you'll find lots of lakes and lots of volcanic mountains. Even the highest mountain of, or highest mountain peak of Africa, that is Kilimanjaro or Mount Kenya, they are volcanic mountains located on East African Rift Valley. There are lots of lakes as well, which are located at this particular ridge. So you can say there is Lake Turkana, that is here. Then you can see Lake Albert. You can see Lake Edward, Lake Kivu, is here. Along with this, Lake Victoria, which gives rise to Nile River, Lake Tanganyika, which is the longest lake here, and Lake Malawi, or also known as Nyasa, is also located on this Rift Valley. So there have been lots of lakes which have been formed because of this rift that has been created. Along with this, we have lots of mountains. Like I said, Mount Kilimanjaro, which is the highest mountain of Africa. Mount Kenya is here. Mount Meru, Mount Tata Hills, North Pare, South Pare, West Usambara, East Usambara, Nguru, Ulugru, Udzungwa, and Mount Hanang. They are also located on the Rift Valley system of Africa, or the Great African Rift Valley. In a near time, you will see that there would be a sea that will be formed, and this complete Somalian subplate, it will break from the African plate. This complete region, it will break down, and there would be a sea that will form in the near future. Near future means not tomorrow or day after, but in few million years ago, after, not ago. All right. So you can see over here how we have the Gulf of Aden Rift, Arabian Plate, Somali Plate. Here we have the Great African Rift, Red Sea Rift, and these are because of the divergence of the plate. And like I said, that this complete part, it will break down in near future. It will break down in future, and that will result into formation of another sea or water body in between. So this is here where you can see that we have the Great African Rift Valley, and there is Arta LA also. It is active volcano that is located on this shield or on this Rift Valley. Mount Kenya and Mount Kilimanjaro are dead volcanoes. Please remember. All right, so that is how we have the crustal upwarp. Later on, Rift Valley is created, and when it gets further widened, it results into formation of sea. And further, if it gets widened, it results into formation of oceans as well. All right. Then comes convergence. Convergent plates or destructive plate margins. What happens is two plates converge towards each other. One plate gets subdued, or it gets subduct in between or beneath the one plate, and when it goes deep inside, of course a part of the crust, it will get melted because of the high temperature, high heat that will be there in the interior of the earth, and thus the name comes destructive plate margin, because a part of the crust that is getting subducted is getting destroyed. So when we talk about the convergent plate boundary, there would be subduction, there would be destruction as well. When it gets subducted, a part of it will get destroyed. It will get destroyed because it will be melted, and that is why it is called as destructive plate margins. So here we have two lithospheric plates which collide against each other, and the example is our own Himalayas. And the subducted material, it gets heated upward and thrown out in the form of volcanic island arc, and that is why when it gets heated and also destroyed, it is called as destructive plate margin. So the divergent plates are constructive, but the convergent plates are destructive. All right. Now, when we are talking about the convergent boundaries, what will happen is when they will collide with each other, if one of the plate is oceanic plate, if one of the plate is oceanic plate, I told you that oceanic plate is denser or heavier. Although oceanic plate is thinner, but it is denser. So what will happen is, if one of the plate is oceanic plate, it will always move downwards, or it will always subduct. So it gets embedded in the asthenosphere of the continental plate, and as a result there would be trenches that will be formed. You can see over here a deep V-shaped valley. So trenches will be formed, like for example, I gave you the example Mariana Trench in the Pacific Ocean, which is the deepest trench with the depth of 11,022 meters, 11,022 meters. So now we can have three different type of convergent boundaries. We can have oceanic convergence, we can have oceanic continent convergence, and continent continent convergence. Now you know that for the oceanic continent convergence there will be always oceanic plate will subside. Always oceanic plates subside. But what happens when we have two similar plates, two same plates, oceanic convergence and continent convergence? So over here we have two same plates, similar plates. So when we have same plates, what will happen? The plate with high velocity, because all the plates are in motion, they are moving on asthenosphere. The plate with high velocity will subside. All right, the plate that will be moving with high velocity, it will subside when we will have the both similar convergence. That is in oceanic convergence and continental convergence. So as the name suggests, when we have oceanic convergence, we have two oceanic plates which subside, which converge or collide, and that results into formation of volcanic island arcs, like for example Japan. In the same manner, when we talk about oceanic continental convergence, it leads to formation of continental arcs or fold mountains, like for example Himalayas. And when we have in the form of fold mountains, like for example it is oceanic continent convergence, like for example Rockies mountains. Rockies mountains have been formed because of the oceanic continental convergence. And when we have continental convergence, there is formation of fold mountains, like for example we have Himalayas. All right. So we have three different types of convergent boundaries. Now, when we have different types of convergent boundaries, what happens is when there is continent convergence. So, in continent convergence, the plate do not subside very deep inside. Like we have Indian plate, which is subsiding beneath the or the Eurasian plate or the Chinese plate. So the subsidence is, it reaches a point where there is a equilibrium that is reached, and it does not, the subsiding plate, it does not create magma. That is why we do not have any volcanoes in Himalayas, but there is earthquake that happens in the Himalayan region, because the plate has not subsided very deep inside into the magmatic or the mantle chamber. So when we talk about the continental convergence, the example is, like I said, it is Himalayas. So what has happened is that for the Himalayas, we had the Indian plate. The Indian plate, it moved towards the Chinese plate or Eurasian plate. So we had the Eurasian plate. We have Eurasian plate. So when they moved towards each other, that led to the formation of, there was Tethys in between, Tethys Sea in between. So in the Tethys, there was debris that was accumulated, or the rivers, they accumulated the weathered minerals, materials into this Tethys Sea. And when they collided, this debris that was collected in the Tethys Sea, that got formed or it got folded in the shape of Himalayas. So we have Trans Himalayas that were formed, Trans Himalayas, in which we have three different ranges. We have Karakoram, Ladakh, and Zaskar ranges. They are part of Trans-Himalayas. They were formed first. They were formed in the same manner. So first, there were Trans-Himalayas that were formed. Second, Greater Himalayas were formed. Then we had Middle Himalayas that were formed. And then at last, we had the Lesser Himalayas or the Shivaliks that were formed in the same manner. This is the chronological sequence. And the Greater Himalayas, Middle Himalayas, and the Lesser Himalayas, they are called as the Himalayas together. They are called as the Himalayas. So that is how we had the Himalayas which were formed, the fold mountains. And like I said, that because the Indian plate has reached an equilibrium where the plate has not subsided beneath a greater depth. So that is why we do not have volcanoes, but the Himalayan region is very particular for the earthquake. There are various earthquakes which have happened right from 1500s, like in Garhwal, Nepal, there was an earthquake of 8.7. And then recently in 2015 in Nepal, we had the earthquake that reached 7.8 Richter scale. So there had been lots of earthquake that hit the Himalayas over the past 500 years. All right. Now comes the another type of the convergence. That is when we talk about the convergence of continent and oceanic convergence. So what happens here is that due to this continent oceanic convergences, there is volcanic arc as well as there are the fold mountains which are created. Just like, for example, Pacific Oceanic Plate and the North American Plate. So what has happened in when we are talking about the Pacific Ocean Plate and we are talking about the North American Plate. So there was the oceanic crust, it will get subsided. This is Pacific Ocean. So this is Pacific Oceanic Plate. And over here we have the North America. So we have North American Plate. So that has resulted into formation of fold mountains like we have Rockies here. In the same manner in the South America we have Andes. So that has resulted into formation of Rockies, fold mountains. It has resulted into formation of volcanoes as well. There are volcanic mountains as well which are located over here. So that happens when we have oceanic continental convergence. All right, so we have the Rockies here. You can see the Rockies as well as we have the Andes which have been formed because of the convergence of Pacific Oceanic Plate and North American and South American Plate. Then if there is oceanic convergence, like I said, that the crust or the plate that will have more velocity will subside and it will lead to formation of island arcs. Like for example, over here you can see that we have Philippine Plate, we have over Amur Plate and Yangtze Plate. Also here we have Sunda Plate. So you can see that we have Philippine Islands which have been created. We have various Philippine Islands and you can see over here we have different volcanoes also. Mount Pinatubo is here, Mount Mayo is here, Mount Balusan is here, Mount Kalon is here, as well as Mount Hibok is here. So they have been created because of this mergence of the or convergence of the oceanic plate. In the same manner, you can see that this is another arc that has been formed, that is Japan. So Japan arc or Japanese island have been formed because of the oceanic convergence. So oceanic convergence will lead to formation of the island arcs. Japan lies on the triple junction. We have Pacific Plate, Philippines Plate as well as Eurasian Plate. And that is why you must have heard that Japan is a country where at least 10 earthquakes hit in a day. Every day there is earthquake on Japan. Although the velocity or the magnitude of the earthquake is not that much high that it can lead to catastrophe. Only certain of the earthquake in Japan have reached that level. And also Japanese have constructed their buildings, earthquake resilient buildings. They have practiced, like when we talk about, Japan. So they have mock drills every certain period of time. After every certain period of time, they conduct mock drills in their offices, in their schools. Even a school going child who is just few years old, he will know how to protect himself during the earthquake. Because Japanese know that they have only one big fear that is coming to them in the near future, and that is hitting by a massive earthquake or by a tsunami. All right. So over here, you can see Caribbean plate as well, where we have Caribbean plate that has resulted into formation of Greater Antilles and Lesser Antilles Islands. And here only we have West Indies that is there. So because of this, you can see we have volcan Tacona that is here, volcan Tajumulco that is located here in Gulf of Mexico that is here. And also Mount Pelee is located in Caribbean islands. These are the active islands that active volcanoes which are there. Volcan Wolf is also located in the Galapagos Island. All right. So the Japanese island that has been formed, or the Indonesian archipelago. What is archipelago? This is another word that we have studied today, another new word that came to our dictionary. Philippine Island arc and the Caribbean islands, they have been formed due to oceanic convergence. Now, what is an archipelago? Archipelago is an extensive group of islands. Yes, it is an extensive group of islands, but it is very important that they lie in a sequence. Either north to south, or either south to north, or either towards east to west. So that forms the archipelago. They occur in a sequence, and that is an archipelago. This is very important. When you define an archipelago, they are extensive group of islands, and this is very important, they occur in a sequence. Like for example, Andaman and Nicobar is also an archipelago. All right. Then island arc is the narrow chain of islands which are volcanic in nature, and they are usually curved. So in oceanic convergence, denser oceanic plate subducts below less dense oceanic plate, and thus there are trenches are also formed along the boundaries. So along the oceanic convergence, there would be island arcs, also trenches that you will see. All right, then comes the conservative or transcurrent or transform edge. So over here, what happens is that there is only lateral subsidence or lateral movement of the layers, and that results into only earthquake. There are earthquakes that happens or that are frequented at these places. All right, like for example, San Andreas Fault that is there in California. All right, San Andreas Fault, it is where? It is in California in USA. So there you will find the conservative or transcurrent or transform fault. All right, there is no creation, no destruction, only deformation, and that is why, because there is no creation, no destruction, it is called as conservative plate. All right. So over here you can see that continental drift theory, seafloor spreading theory, as well as when we talk about the polar wandering and the convective current theory, that gave rise to plate tectonics theory, which was given by Mackenzie and Parker, but later modified and outlined by Morgan. All right, you can go through this table when it will be attached to your PDF. Everything is here. Who explained it, the theory, forces of movement, evidences, drawbacks, acceptance, as well as usefulness. Now, we have certain questions for your mains practice as well. Define mantle plume and explain its role in plate tectonics. This was asked in 2018. Explain the formation of thousands of islands in Indonesian, Philippines, archipelagos. You have to explain the island arcs. Okay. And why are the world's fold mountain systems are located along the margins of continents? Continent-continent convergence. All right, bring out the association between the global distribution of fold mountains and earthquake and volcanoes. So we have different fold mountains that are there, like Andes and also Rockies. They are part of the ring of fire, right? At the same time, the Himalayas, there are lots of earthquakes that happens over here. So you have to bring out the association between the pole mountains and the earthquakes and the volcanoes. All right. Now, any doubt, anyone? Any doubts? So what we have covered today? We have covered today, first thing, geomorphic processes. All right. Both exogenetic and endogenetic. Second, we have covered the plate tectonics theory. My suggestion is just please go through this session once. It is very important to understand the upcoming sessions, whether it is earthquakes, whether it is volcanoes, whether it is formation of the landforms. This session will act as a pivot. It will act as your foundation. And if this session is clear, if plate tectonics is clear, if geomorphic processes are clear, complete geomorphology will be clear as, water. It will be crystal clear for you. Okay. So just browse through it. Just revise it once before coming to the session tomorrow. Thank you. Bye-bye. Take care. Jai Hind. We'll meet again tomorrow at the same time. That is at 11 o'clock. Thank you. Take care. Jai Hind.